Module 6, Chapter 3.8, Polynomial Equations and Inequalities, and Further Applications and Models. Remember that we can use the zero product property to solve quadratic equations. Now we're going to use it to solve some higher degree polynomial equations. Let's review. To solve 3x squared minus 5x minus 12 equals 0, we're going to factor. Well, there's not a greatest common factor. So we do first two have to multiply to give us 3x squared, so we'll do 3x and x. Last two have to multiply to give us a negative 12. So one's a positive and one's a negative. We've got 1 and 12, 2 and 6, 3 and 4, 4 and 3, 6 and 2, and 12 and 1. So let's just pick one, 3 and 4. There's 12 and 3. That one's not going to work. There's 4 and 3. That gives us 9 and 4. We need a negative 9, positive 4. Now set each factor equal to 0. 3x plus 4 equals 0. X minus 3 equals 0. Subtract 4, divide by 3, so we get x is negative 4 thirds. Second side, x minus 3 equals 0, add 3, so we get two solutions of negative 4 thirds and 3. Now we're going to use factor by grouping to solve this x to the third plus 3x squared minus 4x minus 12 equals 0 equation. Now remember factor by grouping. You group the first two, you group the second two. You pull out the greatest common factor of the first two terms, which is x squared, which would leave us with x plus 3. Then you pull out a factor of negative 4 out of the second two terms, which would leave us with x plus 3. Now, because we've got an x plus 3 common in both of those terms, we pull the x plus 3 out, which leaves us with the x squared minus 4. Now, that's not completely factored. So we go down and say, well, x squared minus 4 is a difference of squares. That will factor x minus 2, x plus 2. Now, were we expecting 3 factors? Probably so, since the highest power was 3. So when we set each of these equal to 0, x plus 3 equals 0, x minus 2 equals 0, x plus 2 equals 0. So we get x is negative 3, x is 2, and x is negative 2. So there are our 3 solutions. Now, quadratic equations, remember, are equations that can be put in the form ax squared plus bx plus c equals 0, where a is not 0. A couple of examples are listed below. Now, quadratic in form means that the equation can be put in the form au squared plus bu plus c, where a is not 0 and u is an algebraic expression. What that means is it may not necessarily be an x squared in the first term and an x in the second term, but it may be an expression. For example, 3 times x minus 1 squared plus 5 times x minus 1 plus 2 equals 0. That is what we call quadratic in form, to where the part that's being squared is x minus 1, and then that x minus 1 is also in the middle, so that's quadratic in form, where u is x minus 1. Now the next example, x to the fourth plus 3x squared plus 1 equals 0. That's not quadratic because it's a fourth power, but if you'll think about x to the fourth as being x squared squared, and then we've got an x squared in the middle, so that's quadratic in form, where u is equal to x squared. So to find all complex solutions of this equation, we're going to go back and think about the quadratic in form. Just like we did earlier, we're going to let u be x squared. So at this point, because x to the fourth is x squared squared, that's going to give us u squared minus 6u minus 40 equals 0. Now if we factor that, we get u minus 10 times u plus 4 equals 0. Just like we did earlier, set each factor equal to 0. And we get u minus 10 equals 0, so u is equal to 10. U plus 4 is equal to 0, so u is equal to negative 4. Now remember, u is x squared. So if we substitute back in, we get x squared equals 10, and we get x squared equals negative 4. Now, pulling back in our square root property that says if we've got something of the form something squared equals a number, we can square root both sides. That would give us x equals plus or minus the square root of 10, which that one won't reduce, and we get x equals plus or minus the square root of negative 4, but the square root of negative 4 is 2i, so we get x equals plus or minus 2i. So because the highest power was a 4, we were expecting 4 solutions. So they are positive square root of 10, negative square root of 10, positive 2i, negative 2i. Now this one says find all solutions of the equation x to the third plus 3x squared minus 11x plus 2 equals 0. First thought would be factor by grouping, but if you try that, you're going to realize that you don't get the same factor when you group it, therefore that one's not going to factor. So we're going to do this one on our calculator. Okay, so we're going to enter x to the third plus 3x squared minus 11x plus 2. y2 is the right side, y2 is 0. Graph it. Now remember, we're looking for 3 solutions. We see the 3x intercept, so we just find them. Second, calculate number 5, enter, enter, enter. So our first solution is 0.19. Doing it again, second, calculate number 5, enter, enter. Put your cursor on the next one, and we get intersection of 2, so the second solution is 2. For the third one, second, calculate number 5. Whoops. For the third one, we're going to do second, calculate number 5. Enter, enter. Move your cursor back closest to that one, and we would get a third solution of negative 5.19. Now this one says find all solutions of the equation x to the third plus 3x squared minus 19x minus 57 equals 0. Verified on the calculator by using the window negative 10 to 10 by negative 100 to 50. Y equals x to the third plus 3x squared minus 19x minus 57. Y2 is 0. Now back on our regular screen, we don't get all of the graph. We see the 3x intercepts, but we don't see the comprehensive graph. But we can still do it. Second, calculate number 5, enter, enter, enter. And we get the x-intercept is negative 3. If we wanted to do it again, second, calculate number 5, enter, enter. Put your cursor on the other one, which gives us negative 4.36. And then the next one, second, calculate number 5, enter, enter. Now, where it says guess, if I just want to punch in a number 10, which would put me way over there, that'll work. That puts the cursor here, so it's going to pull off the closest point. So that says that x is 4.36. Now, the only difference if we change these windows, we've still got x's to go from negative 10 to 10. We've got y's to go from negative 100 to 50. All that's going to do is it's going to show us the graph a little bit better, but our x-intercepts are not going to change any. Now, find all solutions of the equation x to the fourth plus 17x squared plus 16 equals 0. And then we're going to verify on the calculator. Okay, so we do the same thing. This is one of those x to the fourth plus 17x squared plus 16. It's not quadratic, but it's quadratic in form. If we let u be x squared, then we get u squared plus 17u plus 16 equals 0. That one's going to factor u plus 1, u plus 16 equals 0. So u is equal to negative 1, and u is equal to negative 16. Now remember, we've got to substitute back to get it in terms of x. So x squared is negative 1, and x squared is negative 16. Square rooting both sides gives us plus or minus the square root of 1, which gives us plus or minus I. Second side square rooting gives us plus or minus the square root of negative 16, or plus or minus 4i. Now notice on the calculator on this one, now if we graph that, we get a graph that looks like that. Let's go back to Zoom 6 and see if that helps us. That doesn't help us at all, so let's use their window suggestion, and let's go from x is negative 4 to 4. And then let's do our y's from negative 10 to 40. So now when we graph that, if you'll notice, we've got an x to the fourth graph. It never crosses the x-axis, which means there are no real solutions, which means all four of our solutions are imaginary. Okay, let's do another one. Let p of x be x to the third minus 3x squared minus 6x plus 8. Use the graph of p to solve p of x equals 0, p of x is greater than 0, and p of x is less than 0. So to solve the equals to, we're going to go to y equals, we're going to enter that x to the third minus 3x squared minus 6x plus 8. Okay, we're looking for the three solutions or the three x-intercepts. So second trace number 5, enter for the first one. So we get x is 1. Second trace number 5, enter. Answer would be 4. And then for the third one, second, calculate number 5, enter. I'm just going to punch in negative 5 to put the cursor back there somewhere. And we get negative 2. Now we're looking to find where p of x is greater than 0. This means where the function values are above 0 or the function values are positive. Well, if you notice, it's positive everywhere between negative 2 and 1. So p of x is greater than 0 for x between negative 2 and positive 1. So p of x, so p of x is positive between negative 2 and positive 1. So we would say x is between negative 2 and 1. Now, for the equation or the inequality px is less than 0, we know that it's less than 0 okay, it's also above the x-axis over here from 4 on, so we say also for x is greater than 4. P of x is less than 0 down here, so it's less than 0. Actually starts right here for x is less than -2. Okay, so our solution set would be from -2 to 1 and from 4 to infinity. Now, when we start doing where the function is less than 0, the first side is back here, which we would say x is less than -2. And then it's also below the x-axis right here between 1 and 4. So interval notation says it's from -infinity to -2 and from 1 until 4. Now, let p of x be 0.86 x to the third minus 5.24 x squared plus 3.55 x plus 7.84. This is one that there's no way we would want to try and solve this one by the graphing method. So we're definitely going to want to use our calculator. So if we enter 0.86 x to the third minus 5.24 x to the second plus 3.55 x plus 7.84. Graph that. That's an x to the third, so we're expecting our 3 solutions. And we're going to do it exactly like we did earlier. Doing second, calculate number 5, we end up with the 3 solutions. So by doing the intersection 5 times, we come up with our solutions as -0.88, 2.03, and 5.13. Now we have another theorem that says if n is a positive integer and k is a non-zero complex number, then the equation x to the n equals k has exactly n solutions. So if this is find the all find all complex roots of the equation x squared equals -9, we know there are 2 complex solutions. X squared equals -9. Square root property says x is positive or negative square root of -9. So x is positive or negative. So x is positive or negative 3i. If we are finding all 4 complex fourth roots, that means x to the 4th is equal to 81. Now in this case, we could fourth both sides. So we get x equals plus or minus the square root of 3, which would be positive square root of 3, negative square root of 3, let's try factoring. That would be x to the fourth minus 81 equals 0. Or that would factor x squared minus 9, x squared plus 9, which this would factor x minus 3, x plus 3. Now, x squared plus 9 will not factor, so we get x equals 3. When we set this one equal to 0, we get x equals negative 3. When we set this one equal to 0, we get x squared equals negative 9. Now when we square root, we get plus or minus the square root of, negative 9, so x equals plus or minus 3i. Okay, now this one, it says find all four complex fourth roots of the equation, of 81. Find all complex fourth roots of 81. So that means x to the fourth is equal to 81. Now, if we think of this one in terms of factoring, that's x to the fourth minus 81 equals 0, which would factor a difference of squares, x minus 9 times x squared minus 9 times x squared plus 9 equals 0, which x squared minus 9 is a difference of squares. X squared plus 9, remember, is a sum of squares that will not factor. So when we go through and set all these equal to 0, we get x minus 3 is 0. X plus 3 equals 0. X squared plus 9 equals 0. Well, this one gives us x equals 3. This one gives us x equals negative 3. This one gives us x squared equals negative 9. Now, applying the square root property on that would give us plus or minus 3i. So your solutions are plus or minus 3 and plus or minus 3i. Now for our application. A box with an open top is to be constructed from a rectangular 12-inch by 20-inch piece of cardboard by cutting equal size squares from each corner and folding up the sides. Okay, let's think about this for a minute. Here's our rectangle. This is 12 and this is 20, and we want to cut an X square out of each corner, and then we're going to fold that box up using the sides as the edges. Now, if X represents the length of each side of the square, determine a function B that describes the volume of the box in terms of X. Well, if we take these little squares out and it tells us that the side of this square is X, okay, then our new length becomes 20, take out this X, take out this X, which would be 20 minus 2X. The new width would be, it originally was 12, and if we take out 2 X's, would be 12 minus 2X. And it says find a function V for volume, so the height of this box is going to be X. So the volume would be the length times the width times the height. This was our length, this was our width, this was the height. Now, determine the value of X for which the volume of the box is maximized. That means we want to find the maximum of this function. So if we go onto our calculator, and enter this x times 12 minus 2x times 20 minus 2x and graph that, we're going to get a graph that looks like that. That doesn't help us a lot. Zoom 0. That doesn't help us a lot. Let's zoom out with zoom 3. Okay. Now, let's zoom in just to get around. Let's move our cursor right up here in the middle. Put our cursor right here, so when we press enter, it's going to zoom us in around. So if you'll notice, we do have a little maximum in there. So to second calculate the maximum, we're going to go left of the highest point. Press enter. Then we're going to go to the right of the highest point. Press enter, which says that the highest point is actually x equals 2.427, and the y value is 262.68. What that means is the highest volume occurs when x is 2.42, or we'll just call it 2.43. So x is 2.43. Now, what would the volume be when x is 2.43? The volume would be 262.68. Now, you're ready to complete this section of homework on my math lab. After you've taken notes from each of these 4 sections and completed each homework with a grade of at least 70%, you are ready to take the Module 6 quiz. Now, after passing the Module 6 quiz, you will need to pass the midterm before quizzing on Module 7. The midterm will cover Modules 1 through 6. It will work the same way as all of the other tests. You can retake it as many times as you want. And I think there's about 15 questions on this midterm. Good luck.